Okay, let's continue with Croof, which is our simple language for solving math problems. And for today, I was thinking to continue the idea of adding sets. And this time we can try to add sets other than natural numbers that, let's say, can have different items. For instance, we can have a boolean as a set with true and false. And I mean, we can even use 0 and 1 as true and false, but I would like to add these as strings. But right now we don't have strings in the language, so if we go in here, you can see that we only have numbers as literals, but I would like to add strings. So the next thing that we are gonna have, or I guess be able to tokenize, let's say string.croof. I might even have a folder with examples and test cases. I think that's gonna be a good idea, but I'm gonna create those on my own, but it's gonna be like really incremental with going from basics like defining numbers to defining your own sets. But I think for now, how I would like this thing to work is you would say define the name of the set, then an equal sign, then you would have curly braces for defining the set, and then inside of strings I could add the values of the literals. So for today, yeah, let's try to parse the literals, the string literals, and maybe even write some functions um, for this thing. So yeah, let's see. I'm curious how this is gonna go. So let's first of all go into the lexer. This is the first step that we need to make, and that's adding something similar to number. So we are gonna call it string probably, or maybe just literal or symbol. I guess I'm gonna call it a symbol. And it's like a symbol from, or I guess literal, right? Fine, let's call it literal. Now it's interesting. I mean, even number could be a literal, but if we already have it, let's just keep it because it's like a base type kind of. Like strings are not gonna be of type string, like number is of type natural number, but yeah, hopefully that makes sense. So what is gonna happen now? I guess in here we'll have to make a new case, right? And we already did string parsing at some point, I think in the makefile project, right? And the idea there, it was quite similar. I mean, it's the same code, but it's written in C, was that once we found a quote, so we can even just say double quote, what we are supposed to do, I guess we should just return self.tokenize string. And I'm not gonna read the character. We are gonna make sure inside of tokenize string that we read it. So let's go maybe somewhere here and let's add our function. So function tokenize string, right? So similar to tokenize identifier, it should accept the mutable self. So it's gonna update some things. It's gonna update basically the read position, the current character, things like that. So it needs to be mutable, and it's gonna return a token. Right, similar to this one. Then what we can have as the first case is if our character is not equal to double quote, we are just gonna do token illegal, and that's just to make sure that if you call this one maybe in a test case or like unit tests to also cover this case. Yeah, I don't know. Okay, after we do that, we should skip our current character. So let's do self.read, right? I don't know why I had a not there, but yeah, whatever. And inside of the makefile project, we didn't really have escaping, but I mean, we did here. We are escaping double quotes, so I guess that works. So what I could do here is while self.ch is not equal to double quote, well, I'm gonna do the same like we did here, right? We create our value, and while we have that, we are gonna read and push a character in the new string, right? Okay, and the last thing would be, okay, but what if we want to escape characters, right, in our string? Maybe we want to escape just double quotes, but maybe we have other things as well. So before actually pushing the character, what we should do maybe is having something like let mutable character is equal to self.ch, right? And then maybe we can match the character. Actually, maybe we can match on the character. I guess we can even do it in a shorter format like this. So we can match it. And if we find, for instance, in the C code, we said that if we find, or like in the makefile project, we said that if we found a backslash, then we are interested in the next character as well. Okay, I guess fair enough. Maybe I want to, because I want to read the next character. But we have a peek function, so it's not that important. So if we find backslash, then we're gonna do some stuff. If we find anything else, we are just gonna return the character. So ch goes into ch, right? But if we find backslash, then we have to read the next character. So self.read. And now it's another important one. I guess anything that comes after backslash is just going to be the character. So I'm just going to do self.read, maybe that's enough. So we just read the next character. That could work, I guess. And here we just push that and then we read it again, right? And we need to create a token value, token kind is string, or I guess literal, and the value is value. Okay. What do you want? Oh. Okay, so this should tokenize the string. Now, yeah, maybe we want to do more stuff here. I don't know. Don't think it matters. So let's just leave it like this. All right. So again, if we go ahead and run it on the string.croof, maybe with a -L to stop at the Lexer stage, we should be able to see. I don't know why it kept going. Oh, okay, I guess I forgot. So in here I have to do another self.read, right? To skip the last double quote. Okay. So you can see that now we have a def, we have type boolean, equal, left brace, a literal, comma, literal, and a right brace. Okay. Okay, so now that we have the string token, we should go ahead and update the parser, because at this point, like the type node is gonna stay the same. Oh, and no, it's fine. Quantifier node. The set node is gonna contain some expressions. This stays the same, doesn't really change. And what something else that I added, like I guess yesterday, was I've made this type node like an extra type node on the AST, and this way we can actually modify the AST to also contain type information. So after we call the type checker, each node is going to have a type basically in the AST. So that's kind of maybe useful. We'll see. Because right now we only have one type, which is natural numbers, but now we're trying to add new types. So we'll see how this will help us. Okay, anyways, so number just stays as a token, doesn't really change. Variable node is the same thing. We have function node, we have the operator node, right? And the important part is inside of the expression. So inside of the expression, we have all of these, right? Operators, functions, number, but we also want to have something like literal, which is going to be a literal node. Right now, we don't have the literal node, so we have to add it. So let's go ahead, and I guess I'm just going to copy paste the number node, and I'm just going to call it a literal node. So at this point, this one is important. It has a type, right? So it can be Boolean, it can be whatever. But right now it's just unknown for now. Okay, so let's add all of these things. We have that, so we just are able to print it at this point. Okay, I guess that's decent. So now we just added this extra literal node in our AST. Now, when we have a degree, it is going to complain that, you know, we don't have the match for it. Now we do. It's simply just 0 if we have a literal. That's fine. We have another one right here, which is going to be literal node. Literal node. We'll just print the node. I think that should be it in here. Now what we need to change is interesting is when we parse stuff. So where should that be? So we have parse type, that's fine, just simple. We have parse quantifier, parse expression, and I guess for parse expression, I mean, we have this otherwise, so it's kind of cool that we can just try to run the parser, and it's going to tell us what we need to implement, basically. Oh, I guess inside of the type checker we have some things missing, so let's fix the compiler error first, right? That's the easiest part. So inside of type checker, we probably are missing some match. Whoa, what the fuck? So in case we have expression node literal, well, I'm not sure how to handle it, so I'm just gonna add a to do, right? Right now we'll have to look into the sets, figure out what's missing. So yeah, let's just say to do. Okay, and I guess the last things are gonna be in the solver. Pretty sure about that. So let's move on to the solver. What the fuck that was? Okay, whatever. So here we have literal. Again, I'm not sure what I'm gonna do here, so I'm just gonna do a to-do. We'll see when we get to it. We'll just put that. Okay, another one is in apply mapping. Again, not really sure what we are gonna do, so just add a to-do and we'll see in the errors at runtime basically. Substitute helper, again, same thing. Not exactly sure how it's gonna be implemented because we don't have that much. Built-in helper. I think that this one can be empty because we don't have anything that's built in that deals with literals. Like for numbers, yeah, we do. We use the successor function, right? And for functions, we have also the successor function. But for literals, I don't think we do. So let's just leave it empty. Okay, so what is it complaining now? Well, now it's fine. It's gonna say expected identifier or operator, but we found a type, right? So if we go into string.croof, here it says on the first line that it expected an identifier or operator. And why is that? Well, right now we when we use def, the def keyword, we are using this to define functions or operators. We haven't implemented defining types. So let's add that feature. So inside of the parser, when we are parsing parse defines, so parse define, we should, here we have identifier, operator, but the last case that we can have, or maybe we'll have multiple cases, who knows, is if we have a type, then I want to do self token clone, I guess. So we just parse the type. But now it's also kind of interesting. These two should work with this, but if you define a type, it should be different. So I might have to create another function parse define like function, maybe define let's call it define function, and it's gonna get this. It should return probably like define node or parser error, I guess. Right, so if we have or maybe what I can do, instead of like, it can also be a bit simpler. I guess I can have it like this, right? In Rust, you can put multiple cases in one, right? And we have let symbol is equal to this thing, right? We don't have to do that there. Then we can consume the symbol. Oops. And then we can just move this stuff inside. I know it's kind of meh, like it can be a separate function just because it's kind of a lot of code, but who cares, right? Okay, so here I can just remove that and that. Okay, nice. So it's like, okay, if it's an identifier or operator, we are just gonna use this case, which is basically the function that we were using currently. But since we are adding another case here, it's you know, a decent idea to do it like this. So if it's a token kind type, so if it's token kind type, then let's just do the same with the symbol, because that's the symbol for the type, right? And actually now we are expecting an equal, and we are expecting an equal sign. So instead of colon, we are expecting equal, expected equal after type, but we found something different. Okay, and then we need to parse a set, but I'm not sure if we have that feature. Parse implication, parse statement, parse relation, expression, quantifier type. I don't think we have parse set, honestly, like with braces. That's weird, because I thought that that's an expression. So instead of parse expression, yeah, we have that. Interesting. So we have the set node as a separate thingy. So maybe we want to move this thing into a separate function so that we can reuse it. Parse set. Let's create a separate one, like parse set. So it's gonna be a mutable self, and it's gonna result into a set node or parser error. All right. Honestly, I can just copy paste this entire thing. Like this. And if it's anything besides L brace, we are gonna do expected set, I guess. And instead of doing that, I'm gonna do it like this, and we can just say okay without the semicolon. So this should be just, you know, refactored version that parses a set. Right, so instead of this entire thing, we can just say parse self.parse set, and obviously this can fail. I need a, I don't know, what? Set node. Oh, I have to do something like map, and we want to map the node like expression node set of node. Right, and then we apply the question mark. Okay. And I guess we can do the same thing for all of them, but yeah, like have a separate parser here. I mean, we already have parse type. Not sure why we consume the type token. Parse set. Maybe I have to do the same thing though. What? Yeah, I think I have. Yeah. Do I? consume the comma token, but if it's a right brace, consume the right brace, end of set elements. Interesting. I mean, I'm curious why type token doesn't consume the no more types, exit the loop. Like, it's weird. It should read its own last thing. That's quite curious. Anyway, like parse set does that. Interesting. Here, obviously, it makes sense that you have to do that, but here it's kind of weird. Like, I should maybe just add self.read here. Right, just so we don't have to do it here. Yeah, it's kind of weird. Why do we need to... Not sure why I have to do read. The fuck? Because if we find arrow, then we do that. So we read the type token, we consume it. Then if we don't have any more types, we stop. So it's weird. Why do I... There's 25 parse. So this one, I guess, I don't know, it doesn't feel right. I don't think I have to do a read here. I think it was something weird. Let's have that parse type. I can just say node, obviously, and then we do expression node type node. Right, so it's gonna make it shorter. That's what I meant. Okay. Okay, whatever. Right. So if we have L brace, we parse set, so on. And I mean, if I'm gonna need to do that for identifier or something else, I'm gonna do that, but yeah, who cares? So parse relation, parse statement, parse, where was parse set? Here, parse define. So if we have a type, we parse the equal, we consume the equal token, and then we need to do self.parse set so that we get the set. And what I guess I forgot to do is inside of the define node, we should maybe have different, this should be maybe an enum. So I guess I'm gonna do something like copy paste this, define function node maybe. Define function node. I mean, function node and operator node are the same, so I'm not sure if I want to differentiate between them that much. And then we have define set node. And for a set node, yeah, sure, we have the symbol like the token, but we also need a set. Maybe set node like set. And here is gonna be a set node, right? And as I said, the define node should become an enum. And we should have something like function, define function node, operator, define operator node, and set, define set node. Obviously this is not going to work anymore with new. Let's do it like this. Let's do a new for operator. And let's do a new for set node. So set node, it's a set node, set. Perfect. Then we have display. And I guess we should implement display for each one of these. Obviously. Shit. I mean, yeah, sure, why not? Define operator, define function node. And define set node. Let's use equal. And here it's going to be set. Okay. Here I guess we need to use a match. I don't see another option on self. Let's what one? Let's have here like nodes, and we can just do write node, right? And that's good enough. Fuck. Let me see how it did for expression. I forgot. Oh, it's missing an F. Sure. Whatever. So we have the program node, we define nodes. Okay, that's fine. And now obviously it's gonna complain in parse define, I would assume. Honestly, I think I'm gonna keep them separate like this, just because, you know, like, even though it's the same code, even though it's duplicate code and duplicate code, whatever, it's like, yeah, sure. After identify. Operator, here we should define function node and then define node function, right? We have to do it like this. Similarly to this one, but here it's operator node, and the last thing, so let set is to create the set node. So this should be the identifier. Let's do here type, identifier, or operator. So this should parse the defines properly. I guess the annoying part now is we'll definitely have errors in here. Right. Even this one is interesting. Now instead of holding here a type node, I would change it to a define node, honestly. All right. And then this being a define node, we can just clone it, but not really, because we need a way to get the symbol. So maybe I'm gonna have a function inside of define node, public function, maybe called symbol, and this one is gonna get a cell reference, and I think it should just return a string. So we have a match over self. Now it's interesting. Yeah, no, I think it's fine. So we know that these things should all have like a name, right? So for a function, it's gonna be name, I guess, or what is it? Symbol, yeah, symbol dot value. We have to unwrap, which is not bad because it is what it is. Do I have to clone it? Yeah. Here as well, symbol value dot clone. Idea is, why do we need to do this extra unwrap? Is we set the value of a token to be optional, and the reason why is something like for all doesn't need the value, but we are like 100% sure that once we reach the parser, these things should have a value, like variables, even though it's not really necessary if you create your own tokenizer. But at that point it's like your fault. Like, how do you have a variable without a name? Like, that's weird. Anyway, node symbol dot value dot clone dot unwrap, and I'm pretty sure that someone can, like, but I didn't really have like uh, the mood to add in here all the fields, because you can do that in Rust. That's pretty cool, right? You can have like enums with fields. That's really nice, but who cares? Like, I can make it a string and force you to put a string for every token, but that's kind of useless. Okay, anyway, so let's go back to type checker. So now instead of calling this stuff, we can just call the symbol function, and then we can just maybe clone the symbol, like the define, I guess. Okay, now this one is interesting. Here we need to create a define. So the define is gonna be define node function, then we have to say function define function. Oops. Define function node, we give it new. We need a token for the name, and then a type node for the type. So we have that. We don't have the token for the name, so let's do token value, token kind identifier, and function soup is the name of the function. So I know it's like we don't really need the function name, but it's still cool to have it. It's like whatever, you can have it in here, it's fine. So here we define the successor function, we fix that. Okay, so here, if we have a function, we should get the function name, obviously. Then inside of the defines, we should try to get that thing. Now, thing is that symbols defines the type node. Yeah, I mean, it's still fine. Like symbols is gonna be symbols like this with string and type node. I don't think I want to do it another way. So it's kind of this part. So this one is a get. Let me just do it like this. So this one is gonna return option. If I do a map, I can do a map. Yeah, I can do a map. And let's say we have a define, right? And I'm gonna do a match on that define. So match define. And we have multiple cases here. We have function, operator, or set. But if we have, interesting, this function returns u, but nah, I mean, if it's, I can even do a match here, honestly. So if it's sum define node function, let's say node, otherwise we just return none. Right, and on this case, if we have a node and it's a function, we should just do node.type node. And here I guess it's gonna say that it's it expects like sum, and it wants it to be cloned. Devil. Fuck. Ah, it wants a what the fuck? It's a reference. Interesting. Whatever. I mean, it's Rust. Just make it happy, and you are gonna be happy as well. So here we are gonna get the function type if it exists, because you know, if in the defines you might have like an operator with that, but it's impossible. So we just search for it, we get the types, and then we do the same stuff like we did here. Then what happens for the operator is that we do the same stuff. We need to have a match on the operator, and let's fill the arms. Define node operator. I guess define operator node. Oh, no. It's just node. I don't need the entire stuff. Okay. So it's node, type node. Let's get sum, and here it's anything else is none. Okay. So this should work, right? Because we changed our, like, how the defines looks like. That was all that was happening here. So the rest of the stuff should stay the same. I would say. Let's see what other errors we have. I think we might have some errors. Interesting. So we have, yeah, nice. So it compiles. That's perfect. So inside of string Croof, it complains that at column 13, so this true statement is not expected, and that what sucks about this thing is that it doesn't also print but no, that's fine. I was thinking that it hit the to do, but no, it was fine. So inside of the parser, it says that it expects an expression, but so we can actually search for this error message, and we might be able to find it. So how many do we have? One. So it's happening exactly here. So in this parse expression, we should also check token kind literal. Token kind literal. Then what do we have to do? Same stuff like number. We just read the literal token, and we do a literal node. So this should in fact parse our define, which is kind of cool. True or false. I guess I should add quotes or something on this thing. Yeah, and let's just leave it like this for now. Like maybe we want to add some quotes. I would have to think that in Rust escape string, we also want to escape a string, but is that a thing? It's a crate? The fuck? Anyway, so like it's maybe just to do just for visuals, maybe escape string, because we might have double quotes inside of the string, and that's not gonna show properly if you, I don't know, render to something. Anyway, but that's kind of all when it comes to the actual definition. So that's cool. Let's go to string.croof and let's try to add a function. So maybe define I don't know, like 0. Let's say the function is 0, its natural number to boolean, right? So this should still work. Interesting. If I do type checking, so we don't have any errors in the type checker. That's cool. And let's say for all a in n, maybe we don't have operator, like too many operators. So let's just pretend that 0 of a is equal to false. And let's just pretend that that's true. So obviously we hit a to do, right? At line 57 in the type checker. Like, it would be cool if I was able to say a is greater than 0, right? But this doesn't work right now. We have to implement it. So let's go into the type checker, line 57. So we hit this to do. Okay. So what do we want to do in this case? Well, one thing would be to look in the defines, look for sets, and see if my literal node is in that set, right? Or at least in one of the sets from our defines. So what I'm gonna do is probably a for loop for define in self-defines, but this is a hash map. Doesn't really matter. Can I iterate them or something? I mean, I don't have to call iter, it's gonna call it automatically. So what's define for this? Okay, so it's string and define. Oh, perfect. So it's something that we don't need, and the define itself. All right, so the define node. Now what I'm interested in is a match on define, right? Let's fill the match arms. So if it's function or operator, we don't care, we're not gonna do anything. But if we have a define set node, we would like to do the following. So well, I guess we kind of need the symbol, right? Right here. So what we have to do is check if a literal node is inside of the set. So if define set node dot set contains what exactly? It's a set node, so it contains expressions. Interesting. And literal node is a single literal. So set is set node. I have to say dot elements contains literal node contains it. This one is interesting. So this should be an error because we have expression versus just literal node. But we do have the expression though, so I can just say expression here. We don't need to necessarily look at literal node. Okay, let me just do something here like a to do, just so it shuts up. So if it contains the expression, right? If the given set that we're looking at contains this expression, our literal node, it means that we are fine. We should return symbol as the type, right? So we should say probably something like let type node is equal to sum, and let's create type node new vec token value token kind type, and the type is symbol. It looks exactly like natural numbers. That's kind of cool. Okay, so we created the type, then we should set literal nodes type node to be type node.clone, and we should just return type node. We want mutable fucking borrow. So I should clone this thing, I guess. Oh, what? Ew. So it's doing annoying stuff. This one wants a reference. Do I have to? No. Okay, the fuck is this shit? I have an idea. Let expression is expression.clone. Like, it's Rust is so annoying sometimes. Expression. Oh, what the fuck? So it's like we borrow it here and then we modify it here, but it shouldn't matter. What the fuck is wrong with this? Like, this is clearly safe, right? So then why is it an error in this dumbass language? Man, come on. Mutable borrow. But clearly, like, I can change it because I did. I mean, expression is mutable reference. Yeah, really interesting why it's doing that. Because I don't want to do like expression node literal and then send in the literal. No, that's kind of lame, even if it works. Expected literal node but found yet. Can I just clone? Oh, no. I have to clone the literal shit node. Bruh. Okay, and then make it a reference. So this works, but it's kind of annoying because I create a new one. It's a lot of text, that's what I mean. Anyway, so this, I think it should work. Right, it's gonna check all the sets and it's gonna look for one symbol. If it finds it, then it sets the type of that literal to this. Okay, and the last thing we have to do, in case we don't have a return, is to print an error and probably return none. So here we are gonna print an error. Literal is not defined and we show it. So this is the literal node dot, no, it's fuck, it's simply the literal node. Yeah, literal node dot value, and the name is, I guess it's just like this. I could copy paste it. For this case, so it's called literal node dot value. Sure. So this should pass now, right? But if we go to our string.croof and let's say we capitalize it so it becomes false, it should say that the literal false is not defined, right? And what would happen if we define another set like animals and we add a fox, and here we say that it's equal to fox? It's gonna say left type bool is different than right type animals. Left type bool. I guess the left type of the equal is different than the right type of this. Okay, yeah. I was like, what do I do? False here. Argument 0 type bool is different than function type n. And I think it's fine. The error message, it shows you the line and column, so it's like 617. Okay, so I'm showing the function token. Maybe I want to show the argument. Maybe I'm gonna change it to show the argument. This one is 631, which I think is the equal. So that one's good. I think I want to change this one to be argument. So let's go here and search for argument whatever. So if I format something, I think I should format the argument. So how do I get the argument? I think it's called arg. But arg is an expression. Whoa. Interesting. Is because arg is an expression. You know what would be cool to do is if we had something called token on the expression, and the idea is it gives you the main token of that expression, or like the starting point kind of for this format. And I think that could be useful, but it's like only for printing errors. So it should be called pubfn token, so it gets a reference to self, and obviously it returns token. So let's have a match self, right? So if it's a set, I don't know what to do. If it's a type, I'm not sure. If it's a number, we just return the value. I think I have to clone it. Okay, if it's a literal node, then we also have a value. If it's a variable, we also have, well, we don't have a, we have a name. If it's a function, then we also have a name. If it's an operator, I think we have something like operator, right? And if it's a parenthesis, I think we need to call it recursively on the expression. So I think we have to say dot token here. And I think this should help with this kind of thing. So in here, if I run this thing, it's gonna say 622. So now if we go into the string Croof, this is gonna be 620. So it's gonna show us the argument that's wrong. That's kind of neat. Okay, anyways, so we are now able to have this kind of functions. So how about, so 0 of a is equal to false. What if we try to evaluate 0 of 0? So this type checking should work, but what if we just run it? Okay, so it panics. It means that we haven't implemented something on line 92. So if we find a literal, when we try to apply the mapping, that's interesting. So we try to apply a mapping. I think it's just some expression.clone. I think it's the same thing like number. Let's see. The result is false. It's cool, but I'm pretty sure we have more things to do, because create mapping helper. This one should be kind of like the number. So if you're mapping, ideally if you are mapping, if you're trying to do a mapping from a string literal to another string literal, you need to check that the other thing is also string literal. So this is the to node, this is the from node, but the only difference with number is x, despite the values being equal, we also need to check that the types are equal. So to node dot type node is equal to from node dot type node. Otherwise it's false. So you need to make sure that the types are equal, right? Okay. And I think there was another to do in substitute helper, which should just be copy pasted like everything else, like this, because here we just copy paste these things. So we just try to make sure that we create a mapping and then we apply the mapping. So that's all we do for the literal in here. So if we run this thing, it should still work. That's pretty nice. Let's actually implement some functions for all a in bool, for all b in bool. I mean, it doesn't really work. I would have to implement the following. Define and goes from boolean to boolean to boolean, right? And then we have to define these options. So I think I have to do true and true is equal to true. This should make sense. True and false is false. False and true is false. And false and false is false. So if we evaluate, let's say we just evaluate true, just to see what happens. So we don't have expected type identifier or operator. Okay, so it's just that I didn't take this one into account, like being able to define operators like this. Right, I only did it for functions. So let's add it. So that happens in the parser when we are trying to parse what exactly expected type or what. Okay. Oh, and it's also that we found illegal. So it means that inside of the lexer we should add and as a valid character. I think I can do something like plus minus star slash equals then greater than caret and contains C. Can I can. So it's a bit easier. Okay, anyways. Result. Oh. Oh. Oh, so in parser it didn't matter. That's interesting. Where is parse implication? Ah, it's parsing an expression. Yeah, that's fine then. So the conclusion here, it's parsing statements, so that's fine. Okay, let's go into string Croof and let's say true and true. Error solving. Solver. I would like to see all the substitutions that we generate. So we are using BFS. Let's do something like, oh, but not, I don't care the built-in. I only want to see these ones. So let's go print ln. So we have an expression, we have a substitution, and we have the implication that we used. So expression, substitution, and implication. Let's see what it tries. Nothing? What the fuck? The expression, what is wrong with this one? True and true. I mean, we should have some implications. I mean, yeah, we do. You can see them. But then why didn't it work? I'm curious. So we had operator first. We had an operator first. And we also have the implication. Let's see. Yeah. I mean, substitute left and substitute right are not gonna work because they are not right. But then when we get to create mapping helper, what, maybe something wrong with the type? To node is equal to, we don't have a type on our node because we didn't run type checking on the expression that we're trying to evaluate. That's right. So what happens here with the type checker is that we type check the implications, but we don't type check the expressions that we're evaluating. So maybe I have to do that as well. For eval in evaluations, type checker dot check expression. It's interesting. So check expression also takes in some symbols. Right now we don't have any, so it's gonna be default. But I think eval is fine. Yeah. So I'm gonna do here eval and maybe hash map default or something. It wants a reference. So I think I have to type check the evaluations as well. Whoa, nice. See, so now it knows the types of the evaluation. Does it still work with test Croof? Oh, I'm printing all of that crap and it makes it slow. So inside of the solver we have some prints that I have to remove. Right, so it's much faster if you don't show the prints. That's decent. And I hadn't planned to add this thing because what if you try to evaluate 1 plus true? I mean, 1 and true, which doesn't make sense. Right, so it's gonna say, I mean, it gives you the error. I would have to stop. If you find a type checker error, you should stop the execution, I think. So this one gives me an option. This one doesn't return anything. So I might want to return here something like option, maybe even nothing. Right. Here we have application conditions. Right, maybe I want to return something just to indicate that the type checker had an error or it didn't. And yeah, I don't know, like option nothing was my best bet. So here, for instance, or I mean maybe boolean, but just to keep it like in theme. So if you have a quantifier, yeah, I don't know though, but it would be nice to stop the execution if you have an error. Check statement. Like check expression returns an option, right? But check statement doesn't. Statement relation, but only this thing can actually fail. So yeah. I mean, sure, why not? Let's just have option nothing. Here then I can do some nothing, and then on this case where we have this thing, if you have an error, I would return none, right? Like return none probably. Here I can return nothing because it's fine. And on any other case, if you had an error, basically that's what this means. We should return none. Okay, and now this thing returns option. So what I can do is make this thing also return option. But how can I keep it like a bit simpler? It could even return boolean, this thing. Oh, I know. So we are gonna have let mutable result is equal to sum, like that, and then we can do result is equal to this thing map or map n maybe, and the result, right? So this should give us an option result, because it's the same thing as a boolean, but yeah. So now the type checker is gonna return something. So type check, maybe it's also gonna be immutable. I mean, honestly, let's make it boolean. Let's make it boolean because why not? Okay, and then check statement is also gonna be a boolean. So here it's gonna return true because it is what it is. Here it's gonna return false, true, false, right? So now at this point, this is boolean. Let mutable type checker result. Let's pretend it's true. Can I even do? Oh no. Type checker result. Okay. And here, type checker result is this map or no, is sum and type checker result. All right, and then if not type checker result, return error or something, I don't know. I guess I can just panic type checking failed something, I guess. So this shouldn't, the fuck? Ah, shit. Okay, whatever. Let's leave it like I just realized it's maybe a better idea, because check expression is gonna return something anyways. So what I could do instead, I guess, is just have something like failed or result and have it a boolean, and here like result true, right? And then this can be immutable here, and when I have an error I can do self result is equal to false, and that's that, right? Much simpler. It's a OP, baby. So But the question is, damn, but this way what happens? Does it become stupid or something? I guess so. Yeah, it's a fucking line. So let's just leave it. Whatever. I have to figure out a way to do that because yeah, maybe it's gonna be, I don't know, type checker expression besides just the option should also return something else like a boolean if it worked or not. Right. But not exactly sure. But yeah, anyway, so we have some progress here. We are able to create sets now with custom things, right? That's pretty cool. We can already define functions, but you know, the actually cool thing would be to have something like we do here with 0. If we had something like a is greater than 0 and then a0, then well, that's the base case. So we can even just say something like this. All right, so we basically define functions. I mean, you know, it could work if we do it like this and we say 0 of 0. It's probably gonna say true because we are lucky, but if we put it the other way around, it's gonna say false. No, so it's kind of there, but it's not really there. So yeah, expect equal found then. So we have now it thinks that greater than is an operator or something, right? I mean, it's not defined anyways, so yeah. Ooh, that's curious. So maybe we want to define greater than to be actually something like equalities. All right. So yeah, maybe something like that. But you know, that's gonna be for some other time. So you know, I'm pretty happy with the results so far. So you know, we are able to evaluate true and what if I do and false? Will it know to say false? That's kind of cool. Okay, so you know, would be nice now to have something like oh, so what would happen if I also add test.croof? Right, and add parentheses on this thing. So it combines both files. That's cool. But see here, the type is n. It doesn't really check the types. So that's also gonna be interesting to do. Actually checking the types. So yeah, I guess for now it's a decent result. So yeah, let's see in the next one. So until